So imagine having the power of an enterprise-grade AI coding assistant right there inside your editor. Now, normally, tools like that are going to cost you hundreds of dollars a year in subscription fees, right? Not to mention, they kind of secretly bean your proprietary code up to a corporate cloud. But what if it was entirely private? What if it was completely free and running literally right on your own machine? Well, welcome to This Explainer. Today, we're going to walk through a seamless roadmap to bridge a locally running AI model with your daily development environment. If you've been wanting to combine the absolute data sovereignty of local LLMs with the convenience of an inline code editor, you are absolutely in the right place.
Okay, let's take a quick look at our roadmap for today. We're breaking this down into 4 simple parts: loading the local model, getting the Continue extension, configuring that AI connection, and finally, testing out your brand new local copilot. Let's dive right into section 1, loading the local model, or basically firing up the engine. At a high level, we're essentially building a bridge between 2 completely separate islands of software. And to do that, we're following a really clean 3-step roadmap from our source material. First, we start our AI host, which is LM Studio. Second, we get our code editor ready by installing an extension in Visual Studio Code. And third, we just make them shake hands and connect. We'll start things off over on the engine side, and we're going to assume you've already got LM Studio installed and ready to roll on your Windows machine. Once you open up LM Studio, you'll see the interface is super straightforward. First thing we got to do is tell the software which brain to use, right? So you just click that Select Model to Load button at the top. This drops down a list of the models you've already downloaded to your machine. In our source example, they're using a model called Gemma 4. And honestly, a model like Gemma 4 is pretty much perfect for this. It's remarkably lightweight, meaning it's designed to run incredibly efficiently on standard consumer hardware. You're not going to melt your laptop CPU, but you're still getting highly capable code generation. You just click on Gemma 4, watch the progress bar fill up as it loads into your system's memory, and boom, your AI is awake. Now, the real magic for these kinds of integrations, that happens over in the Developer tab. Once your model is loaded up, you want to navigate over there. This is where LM Studio actually confirms our model status is officially running. But more importantly, it exposes the exact local URL it's broadcasting on. It tells us it's running on your local host using port 1234. Actually, go ahead and mentally bookmark that exact number, 1234, because that specific port is the vital address our code editor is going to need a bit later to tap into all this local compute power. Moving right along to section 2, getting the Continue extension and preparing our interface.
Okay, so with our engine humming nicely in the background on port 1234, we can actually just minimize LM Studio for a minute. It's time to open up our interface, Visual Studio Code. Now, over in VS Code, we need to add a translator of sorts. Basically, a tool that knows exactly how to route your prompts to our local AI, instead of sending them out to some external server. So head over to the Extensions tab on your sidebar. In the search bar, look for an extension called Continue. Continue is this fantastic open source AI code agent. And the fact that it's open source, that is a massive win for privacy, making it the exact secure bridge we're looking for. Go ahead and hit install, and then verify it by clicking Trust and Install to officially add it to your VS Code environment.
All right, on to section 3, configuring the AI connection, where we're really building that bridge. As soon as that Continue extension finishes installing, you're going to see a brand new icon pop up right there in your VS Code sidebar. Click that icon and the new interface opens up. It's going to prompt you to select a model, so choose Add Chat Model. Now, here's where it gets interesting. This brings up a list of providers, and you're going to see all the big corporate heavyweights right at the top: Anthropic, Azure, Google, the whole shebang. But remember, we're building a private local connection today. It's kind of like a David versus Goliath moment. So you're going to scroll right past those massive cloud providers and their expensive APIs until you find the LM Studio provider. Select that one. And since LM Studio is already running in the background, you don't even need to manually type in the model name. You can literally just leave the model dropdown set to auto-detect. Finally, just hit that connect button to initiate our crucial handshake.
Understanding what clicking connect actually does behind the scenes is incredibly insightful. It doesn't just spin a generic loading wheel and hide the process from you. Instead, it actively generates a configuration file right on your computer. Specifically, inside your system's home folder, it creates a brand new directory named Continue. And right inside that folder, it generates a little file called config.yaml. This text file is the actual hard-coded bridge linking VS Code to LM Studio. That means there's no hidden black box here. You have complete visibility and ultimate control over exactly how your editor is talking to your AI.
And if we look directly at the data written inside that YAML file, it brilliantly reveals just how beautifully simple this connection really is. First up, check out the port value. It's 1234. Remember that number from earlier? VS Code now knows exactly where to listen. The provider is set to LM Studio, and the model is set to auto-detect, which automatically grabbed the Gemma 4 model we loaded way back in step 1. Because LM Studio was already up and running, the Continue extension basically just wrote all this routing information for you flawlessly. The bridge is officially constructed, and the best part? Zero external dependencies.
Once that connection is locked in, you can easily customize your workspace. By default, the Continue chat window is going to sit on the left side of your screen alongside your other Explorer tabs. But hey, if you're used to that classic GitHub Copilot feel, you might really want your AI assistant over on the right side of the screen, and you can mimic that layout in seconds. All you do is click the Toggle Secondary Sidebar option in VS Code to open up a panel on the right. Then, literally just drag and drop the Continue icon from the left sidebar right over to the right sidebar. Just like that, you've got a Copilot-style workspace, tailored exactly how you want it, but powered 100% by your private local model. Finally, let's jump to Section 4, Testing Your Local Copilot. This is the big payoff. Now that our bridge is built and looking good, it's time to open up a demo folder in VS Code and actually take this integration for a test drive in the Continue chat window. We really just want to make sure that data is flowing back and forth correctly. To do that, we're going to submit a very simple prompt. Let's just type "write a C++ program" and hit enter. Now, we are intentionally keeping this prompt pretty light. Since this is a local LLM running entirely on your system's hardware, it's always a solid practice to not accidentally overwhelm your system's resources with some massive, complex request right out of the gate. We're just gently verifying how it reacts to a basic command.
The exact moment you hit enter in VS Code, go ahead and flip back over to the LM Studio developer section. Right there, you'll see this deeply satisfying status update pop up, processing prompt. And right beneath that, you'll see a continuous stream of real-time debug logs just flying by. These logs are absolute gold, honestly. They are definitive proof that your keystrokes successfully traveled from your VS Code editor, completely bypassed the internet, went straight through port 1234, hit your local Gemma 4 model, and are actively generating a response. It perfectly confirms the communication is flawless. Your local model is working hand in hand with VS Code with absolutely zero latency to the outside world. So, by following these few simple steps, you've completely transformed a standalone AI model into a fully functional inline code assistant. You've now got a completely free, entirely private AI coding partner bridged directly into your native development environment. Your proprietary code literally never has to leave your machine. And, let's be real, you never have to pay a monthly subscription fee again. That is incredibly empowering for any developer. Which really leaves us with just one final exciting question for you to ponder today. Now that the bridge is built, what are you going to build with your local AI?